In this video, we're going to look at Prim's algorithm, which is one of the popular algorithms for finding the minimum spanning tree of a graph. We start off by selecting a node. It can be any node in this graph. So let's pick A. We look at the edges of this node and pick the one with the minimum weight. A has two edges. The edge with the minimum weight is the one from A to C. So we add this edge and its target node to our tree and then go to C. Now our tree has two nodes, A and C. We should extend this tree and add another node. But which node? Well, we have to look at all the edges connected to the existing nodes and then pick the one with the minimum weight. These are the edges from A to B, from C to B, and from C to D. We're not considering the edge from B to D because it's not connected to the nodes of our tree. So at each step, we want to maintain a tree. We want to make sure all nodes are connected. So out of all these edges available, the smallest is the one from C to B. So we add this edge and its target node to our tree. Again, we have to look at the edges connected to all the nodes of our tree. We have three edges to pick from. The smallest is the one from B to A, but we have already visited A, so we're not interested in this. The next smallest edge is the one from B to D. We have not visited D yet, so let's add this edge and its target node to our tree. Now we have visited all the nodes and we have a minimum spanning tree. So the idea of Prim's algorithm is to extend the tree by adding the smallest connected edge. This is another example of a greedy algorithm. I've highlighted the word connected here because at each step we want to maintain a tree. So we're not interested in edges that are not connected to the nodes currently in the tree, okay? Now let's talk about implementation. At each step, we want to pick the edge with the minimum weight out of the edges connected to the existing nodes. How are we going to do that? Well, every time we visit a node, we add the edges to unvisited neighbors to a list or pool of available edges. These are the edges that are connected to our tree, right? Now, in this list, we want to pick the edge with the minimum weight. What's the ideal data structure for that? A priority queue. With a priority queue, we can pick the minimum weight edge in constant time. We're going to repeat this until we have added all the nodes of our graph to our spanning tree. Now, how are we going to represent this spanning tree? We can use our weighted graph class. So we don't need to create a new class called spanning tree because a tree is essentially a graph. Our spanning tree is going to have all the nodes of our graph, but with fewer edges, right? So spend 20 minutes on this and then come back, see my solution.